Welcome back, students. Today we shall be discussing the topic of formation of beats. When two harmonic waves of nearly same frequency traveling in a medium along the same direction superpose upon each other, the intensity of the resultant sound at a point in the medium rises and falls periodically with time. Now, these periodic vibrations in the intensity of sound due to the superposition of two sound waves of slightly different frequencies are called beats. Let me just zoom in this picture so that you can have a closer view of what happens exactly when two waves of slightly different frequencies superpose with each other, and that results in the formation of beats. So if the intensity of sound is maximum initially, one beat is formed. When the intensity of sound again becomes maximum after once becoming minimum. The time interval between two successive beats is called the beat period, and the number of beats per second is called the beat frequency. So it is found to be equal to the difference in frequencies of the two superposing harmonic waves that we shall be seeing a bit later. The human ear cannot hear the beats if the beats formed are more than 10 per second. In other words, so that the human ear can detect the beats, the difference in frequencies of the two harmonic waves should not be more than 10. It is because of the persistence of hearing. So let's figure out how beats are formed. Let's first of all try to understand formation of beats through the graphical method. Let us consider two trains of harmonic waves of slightly different frequencies or of slightly different wavelengths traveling in a medium. Suppose the two waves are of frequencies 50 Hz and 40 Hz respectively, and their amplitudes are equal. In 1/5 second, the two waves will cover the same distance. But in this distance, the number of waves due to the first and the second wave trends will be respectively 10 and 8, as you can see. When the two wave trends superpose on each other, the resultant displacement at each point can be found by the principle of superposition. That is, by adding the displacement of the two waves at each point according to the law of vector addition. So the resultant waveform will be, as you can see in this picture. It follows that the amplitude and hence the intensity of the resultant wave becomes maximum, minimum, maximum, minimum, and maximum alternately. So you can see there is a maximum at A, minimum at B, then maximum at C, minimum at D, and maximum at E. As such, it follows that two beats are formed, one between A and C, and the other between C and E. Since the two beats are formed in 1/5 second, the number of beats formed per second will be 10. So that is equal to the difference in frequencies of the two wave trains. Now this was understanding the formation of beats with the help of graph. Let us try to understand this using the analytical method. So suppose we consider two harmonic waves of equal amplitudes but of wavelengths lambda 1 and lambda 2 traveling in a medium in the same direction with same speed along the positive x-axis. Then we may write down y1 to be equal to r sine 2 pi by lambda 1 vt minus x, and y2 to be equal to r sine 2 pi by lambda 2 vt minus x. Now We may write down equation 1 as y1 equal to r sine 2 pi, then v by lambda 1 t minus x by lambda 1. Now as you can see, v by lambda 1 is actually new one. V by lambda gives us frequency, so v by lambda 1 will give us new one. So we may write down y1 to be equal to r sine 2 pi new 1 t minus x by lambda 1, and similarly y2 as r sine 2 pi nu 2 t minus x by lambda 2. So if the listener is situated at x equal to 0, then the variations in the displacement of the two waves at this point will be described by wave functions y1 at x equal to 0 and time t will be equal to r sine 2 pi nu 1 t, and y2 at x equal to 0 and time t will be equal to r sine 2 pi nu 2 t. So according to the principle of superposition, the resultant displacement at x equal to 0 at any time t will be y equal to y1 x equal to 0 t plus y2 x equal to 0 t, and that shall be equal to r sine 2 pi nu 1 t plus r sine 2 pi nu 2 t. So taking out r as common, we may write down sine 2 pi nu 1 t plus sine 2 pi nu 2 t. So using the trigonometric identity, we get y to be equal to r twice of sine 2 pi nu 1 plus nu 2 by 2 times t, and cos of 2 pi nu 1 minus nu 2 by 2 times t. So this may be written as y equal to 2r cos of pi nu 1 plus nu 2 times t, and sine of 2 pi nu 1 plus nu 2 by 2 times t. Now this equation represents a harmonic wave of frequency nu 1 plus nu 2 by 2 and of the amplitude 2r cos pi nu 1, this will be minus nu 2 t. So this equation represents a harmonic wave of frequency nu 1 plus nu 2 by 2 and of amplitude 2r cos pi nu 1 minus nu 2 times t. So this amplitude varies with respect to time. So obviously the resultant amplitude will be maximum if cos pi nu 1 minus nu 2 times t is equal to plus minus 1, or we may write down pi nu 1 minus nu 2 t to be equal to n pi. So this implies t equal to 0, 1 by nu 1 minus nu 2, 2 by nu 1 minus nu 2, 3 by nu 1 minus nu 2, and so on. So thus at x equal to 0, the resultant amplitude and hence the intensity of the sound will become maximum after a fixed time interval equal to 1 by nu 1 minus nu 2. Therefore, frequency of maximum intensity, that is equal to 1 by 1 upon nu 1 minus nu 2, that is equal to nu 1 minus nu 2. Similarly, the resultant amplitude is minimum if cos pi nu 1 minus nu 2 times t is equal to 0, or we may write down pi nu 1 minus nu 2 times t to be equal to 2n plus 1 times pi by 2. Therefore, t becomes equal to 2n plus 1 divided by 2 times nu 1 minus nu 2, where n is equal to 0, 1, 2, and so on. This gives us t to be equal to 1 by 2 times nu 1 minus nu 2, 3 by 2 nu 1 minus nu 2, 5 by 2 nu 1 minus nu 2, and so on. So thus at x equal to 0, the intensity of sound will become minimum after a fixed interval of time equal to 1 by nu 1 minus nu 2. Therefore, frequency of minimum intensity, that is also equal to 1 by 1 minus nu 1 minus nu 2, and that is equal to nu 1 minus nu 2. So thus, the frequencies of maximum intensity and minimum intensity of the sound on superposition of the two waves are equal. The one maximum in intensity will be followed by a minimum and then by a maximum in intensity, and so on. So as one beat is formed when the intensity of sound again becomes maximum after once becoming minimum, the number of beats per second, that is B, which is called the beat frequency, is equal to nu 1 minus nu 2.